Good afternoon, everyone. I wanted to go over quadratic inequalities with you. I'm going to break this down into three different parts. Hopefully, that'll help you when you're actually putting the inequality together. So we're going to start with some basic vocabulary, just basic review. I've got an inequality here. 2x minus 5 is greater than 15. So if you remember, we're just going to solve this basic inequality. Add 5. We're going to get 2x is greater than 20. So x is greater than 10. Now, if we're to graph this using a number line, I would draw my number line, put my number over top of it. I can add a couple of other numbers if I'd like. And we know that this is greater than, so I know that I'm going to put an open dot, and I know that I'm going to shade to the right because I need all the numbers that are greater than 10. So I can repeat that with another problem. 3x less than or equal to negative 15. We know that x is less than or equal to negative 5. So if I'm graphing that, and we've got negative 5, negative 6, negative 7. Know that this now is a shaded dot, and it's going to the left because I need everything that is less than negative 5. And I can even do a compound inequality, something that looks a little bit like this. Negative 2 is less than or equal to x, which is less than or equal to 5. And if I do that one, negative 2, 5. And if we notice here, we want x is between negative 2 and 5. That means we want all the numbers that are between those two values. So I've got a closed dot and a closed dot, and I want everything that is between them. So we're going to shade it in the middle. Now this is all what we used to seeing, but we do want to do a little bit of a different notation now to show you how to write your answers in a slightly different way. So we're going to go to something that's called set notation. So what we want to do is go back to this first problem. We know the answer here is x is greater than 10. Anytime we see an open dot, are going to use a parentheses. So we're going to, because we know that the answer to the question cannot be that value. So we know it's going to be an open dot, and we know that the values that start at values that are greater than 10. Now we know that this is essentially a number line. So sitting way over here, as far out as we could go, is positive infinity, and on the opposite side over here is negative infinity. We want things that go into the right, so head towards positive infinity. So therefore, we're going to end at positive infinity. Now, we never can actually reach infinity, so we close it with a parentheses. So now if we do our next one here, we know that we always go left to right, so we're looking at negative infinity, and then it's going to go to negative 5. But if you realize that dot is closed, so it can be the value, so we close it off with a bracket. And then in this case, we got negative 2 to 5. So we know we've got 2 bracket because it can be the value. It goes, actually negative 2, and it goes all the way to a positive 5. So this should look really familiar to the notation we used when we were doing domain and range. So just kind of give you just a quick summary. We know that if it's an open dot, then that means that we are going to graph our answer with a parentheses, and we know that that means that the cannot be the exact number. But we know if it is a closed dot, then we use our brackets. We know that it can be the exact number. And we know that it's going to be an open dot if it's less than or greater than. And we know that it's a closed dot if it's greater than or equal to, and less than or equal to. So this is a really kind of cheesy way to remember it, but the greater than or equal to and the less than or equal to have the line underneath them, and the bracket is made with lines. So when we use the line, we use the lines underneath the bracket here. Just hopefully that'll help you. All right, so that's kind of part one, a little bit of a review. Let's go to part two. Now part two is a review as well. It's basically based off of what we've been doing the past couple weeks, which is solving. So if I have an equation that looks like this, x plus 7, x minus 5 equals 0. Using the zero product property, I know I can set each of those factors equal to 0. So I could get x plus 7 equals 0, x minus 5 equals 0. So x is 5, x is negative 7. So nothing new. We know we've got the value of x, negative 7, and positive 5. Could also have something that looks a little bit different like this. And in this case, we said all the factors equal to 0, so 3 equals 0, 2x minus 3 equals 0, and x plus 4 equals 0. So 3 never equals 0, so that's not going to produce a solution to this equation. Then we got 2x equals 3, x is negative 3 over 2, and x is negative 4. So we know there we got our answers. Actually, that's a positive 3 over 2. I apologize. Positive 3 over 2 there. And we know we got our answers of x is 3 over 2 and x equals negative 4. All right, so we've got our answers there. So now what we want to do is take both of those pieces and put them together. So that's our part 3. All right, so with part 3, our equations are going to look a little bit like this. X minus 5, x plus 6, and it's greater than 0. So if you notice now, what's a little different here is the fact that we now have an inequality along with the quadratic. So it does change things just slightly. So the first thing we want to do is go ahead and solve this just like we would a normal quadratic. So we're going to set each factor equal to 0. So we got x minus 5 equals 0, so x is 5. And we've got x plus 6 equals 0, and x is negative 6. Now we got to remember it doesn't actually equal these values because we are dealing in an inequality. This is just going to help us solve the problem. So we're going to put both of those values over here on a number line itself. So we're going to put them in, remember this is a number line, so the way the number line works is from least to greatest, so negative 6 and 5. And then what we want to do is just extend that number line a little bit down, and now I've got what we call a chart. So this is what we call a sign chart. So if you ever hear me refer to a sign chart, this is what we're talking about. Now what the sign chart is going to do is it's going to tell me in what places on this number line are the values of x going to give me numbers that are greater than 0 and numbers that are less than 0. So the way that it does that is we look at the first terms in each of these factors. So once it's factored, we're going to take the first term of every factor that we have. So in this case, it's x and x. So I've got x and x, which is a x squared. So that value there is a positive. So we've got a positive times a positive, which is a positive number. That sign, whatever it is, goes to the far right in the first section, right there. Now, every time we jump a line, we change signs. We get a positive, a negative, and a positive. So what this sign chart is telling you then is that anytime you plug a number in that's greater than 5, you're going to get positive values. Anything between negative 6 and 5 is a negative value, and anything less than negative 6 is going to be positive values. So we have to think about what do we want. If you notice, our thing says we want values that are greater than 0. Well, numbers that are greater than 0 are definitely larger or positive numbers. So we want everything that goes this way and everything that goes this way, because we want the positives, numbers that are greater than 0. So then what we can do is write our answer in that new solution set that we've learned. So it would look like this. We know negative infinity to negative 6, 5 to positive infinity. So we know we're looking for those positive answers there because we want values greater than 0. So this is our solution. Now once you understand this, we can actually do quite a few different problems that work very super similar. So we could do something that looks a little bit like this. We have negative 3, x minus 3, x plus 3 is greater than or equal to 0. Okay, so we're going to set each factor. Negative 3 equals 0, x minus 3 equals 0, x plus 3 equals 0. Okay, that can never happen there. And I'm left with x is 3, x is negative 3. So I'm going to draw my number line. Negative 3, 3. Here again, what do I need? Values that are greater than 0. Values that are greater than or equal to 0. Okay, so we know we're going to be doing our positives. So let's see what we've got. We've got negative 3, which is an x and an x. So we're looking at negative, positive, positive. Well, negative times a positive is a negative. So on that far right block is a negative, followed by a positive, because every time we cross a line, we change signs, followed by a negative. Now in this case, remember, we want values that are greater than 0, so those are positives. So we want from here all the way to here, everything where that positive is. So when we write our solution now, we want that middle section. So we know that it's going to be a bracket because it's greater than or equal to -3, +3, and close it off with a bracket. Let's try another one. So let's do one this time with a less than sign. So we're going to do 2x minus 5, x plus 6, less than 0. So we know that x is equal to 5 over 2, x is equal to -6. -6, 5 over 2. And our signs y, 2x, and x. So we got a positive and a positive. Positive times a positive is a positive. Positive, negative, positive. So now in this case, if you notice, we want values that are less than 0. So since we want values that are less than 0, we want that negative, because negative values are less than 0. So we want that section right there. So when we go to write our answer, we get -6, parentheses here again because it's less than 5 over 2. That would be our answer. So like I said, you can do pretty cool stuff with this once you actually get the hang of it. I can do some pretty crazy ones that look like this. 2x minus 4, x minus 7, 3x minus plus 1, 2x plus 5, and let's say less than or equal to 0. So now we get x is equal to 2, x is equal to 7, x is equal to -1/3, x is equal to -5 over 2. So we've got -5 over 2, -1/3, 2, and 7. So we've got a 2x, which is a positive, an x, which is a positive, a 3x, which is a positive, and a 2x, which is a positive. So I've got a positive times a positive times a positive times a positive, which is a positive. So on this end is a positive, negative, positive, negative, positive. Now I want values that are less than or equal to 0. So I want this section right here, and I want this section right here. So my answer then is going to be bracket, -5 over 2, -1/3, bracket 2, 7. Okay. So I'm going to go ahead and put the homework up as well. So if you have questions, come see me during activity, or ask at the homework tomorrow, and I will see you guys later. Bye-bye.